This is lesson 2 about powers and exponents. As an introduction to the idea about powers and exponents, there is a situation that is going to involve some repeated multiplication. And repeated multiplication is a key idea in the concept of powers and exponents. Your little sister decides to start saving money by putting a penny in her piggy bank and then doubling the amount she saves each week. Use the questions below to find how much money she will save in 8 weeks. So I see a table, and question 1 says complete the table to find the amount your sister saved each week and the total amount in the piggy bank. Let's see, across the top of the table we have the weeks numbered, and then this row of the table shows how much money she's saving in that week, and then the last row of the table is showing the total savings in the piggy bank. And so at the start of the process, initially, she puts in 1 cent, and then at the end of that week, she will have in total the 1 cent. Now the following week, she's going to double how much money she puts in the bank, and so she's going to put in 2 cents, and then when you add that to what was in the bank before, there's now a total of 3 cents in the bank. Okay? Now let's continue this pattern by doubling how much she saves each week. If you double 2 cents, that means that your little sister is putting 4 cents in the bank. And then adding to what was in there before, there is now 7 cents total in the bank. Okay, the next week, double this. She's going to put in 8 cents. And when added to what was in there before, there is now 15 cents total. Okay. In the next week, doubling this, she's going to put 16 pennies in her piggy bank. And then adding to what was in there before, there's 31 cents total. Okay. The next week, doubling this, she's going to put 32 cents in the bank. And adding to what was there before is 63 cents. And then one more week in the table. Doubling 32 is 64 cents. And adding 64 to the 63 that was already in there will be $1.27 total in the piggy bank. Okay, now going on. How many 2's are multiplied to find her savings in week 4? Here is week 4. And this first box here is how much money she saves in week 4. 16 cents. So the question was, how many 2's were multiplied to get 16 cents? Okay. And that would be 2 times 2, which is 4, times 2, which was the 8, and then times 2, which was the 16 cents. So there are 4 2's being multiplied to create 16. Then it says, well, what about in week 5? And in week 5, you would multiply by 1 more 2 to get the 32 cents. And so 5 2's were multiplied. Okay. Now question 3. How much money will she save in week 8? Okay. Well, the table doesn't go all the way to week 8, but if we added 1 more column on there to be week 7 and doubled that, 64 plus 64, that would be $1.28. And then 1 more time, we could create another column to be week 8 by doubling this. So $1.28 times 2 is $2.56. So that right there is $2.56. Okay. Now continue the table to find when she will have enough to buy a pair of shoes for $80. Okay, and here I've extended the table. So up here I figured out for the 7th week and how much money she saves that week, and then adding to what was in there before, getting the total. Then again for the 8th week, and then down here I've extended the table even farther for the 9th week and then the 10th week the 11th week, and finally the 12th week, where she saves $40.96, which can be combined with what was in there before to create $81.91. And that is enough to buy the pair of shoes for $80. So it will take 12 weeks for your little sister to save enough money to get those shoes. Now, the point of that problem was to give you a real-life situation that involved some repeated multiplication, some recognizing patterns to make it easier to figure out what number comes next, or to figure out how this number is added to this one that's just one less, to create this total, and so on. So all the work that we did with patterns is going to become important to what we're working on in today's lesson. So the key concept for today is a product of repeated factors can be expressed as a power. And what a power is, it's a math expression that has an exponent and a base. So you might put a star by this. This is today's key concept for the lesson. Now here's a quick sample of what a power looks like and what an exponent is and what a base is. So here's a product of repeated factors. The factors are 2's, and 5 of them are being multiplied together. And here is how you can write that using a power. This number here is called the base, and this little number in the upper corner is called an exponent. And the exponent indicates how many times the base is being multiplied together. So another way to write 2 times 2 times 2 times 2 times 2 in a shorter way is to write 2 to the 5th power. Okay? Now the next key concept has to do with how you actually speak these powers out loud when you see them. So when you see the symbols, how do you actually say them out loud, or even in your head, how do you read them to yourself? So this symbol right here is read 3 to the 1st power. And here's what it means, that you have a 3, a single 3. This symbol here is read 3 to the 2nd power, or you can also say 3 squared. It's quite common to say 3 squared, and that means that there's an exponent of 2. And here's what it means, 3 times 3. Okay? This right here is 3 to the 3rd power, or you could say 3 cubed. It's very common to say 3 cubed instead of saying 3 to the 3rd power. Okay? Now we're going to put these key concepts together and do some example math problems with them. I'm going to work a couple out for your notes, and then I'll pause and let you try some, and then the answer will be shown in the video. Okay? So first question, write each expression using exponents. Okay? So what we're asked to do is, instead of having this written all out as a product of many factors, to write it in a more compact way using exponents. Okay? First thing I'm going to do is look for bases, or that is numbers that appear more than once. I notice that -2, -2, -2. I can see 3 -2's being multiplied together. So in my answer, I'm going to write -2, that's called a base, and then indicate using an exponent that there were 3 of those multiplied together. Now that's not the only part of the answer, because there's another number that's also repeatedly multiplied together, and that is the number 3. And so I'm going to say times, and then write down 3 as a base, and then determine its exponent to say how many 3's there were. And there are 4 of them. And so this expression here is how you can write out this long multiplication problem using powers. Okay? Now as a second example, number 2. It's the same situation if we have variables instead of numbers. Okay? First of all, I see the letter A. And then as I look across here, are there any more letter A's? Yes, there is. So the variable A, I'm going to write down, it is a base, and then I determine an exponent to put in the corner to say how many A's there are. And there are 2 of them, so A to the 2nd power. Okay? Well, that's not the only thing, so now times, there's also the letter B used as a base. And so I need the letter B and then an exponent. I see 1, 2, 3 B's. And so I'm going to put a 3 in the upper corner to be the exponent. So A to the second power times B to the third power is how you can write this multiplication problem using powers. Another way to say this is A squared times B cubed. Please try number 3, 4, and 5 on your own, and then the answer will be shown in the video in a moment. And here are the answers for 3, 4, and 5. So in number 3, the base is the number 1/2, and then there are 3 of them, and so its exponent needs to be a 3. Please notice how I have the base written in parentheses, and the reason I did that is so that it did not look like this, where it's hard to tell if the exponent belongs only with the 1 or is the exponent on the fraction. That's a little vague, so instead of writing that, I use parentheses around that to clear that up. Okay, here's problem 4, and then problem 5 using letters of the alphabet instead of numbers. Here's what that answer looks like. Now, the next key concept, still having to do with powers and exponents, to evaluate a power. Write it as a product of repeated factors, and then simplify. So the directions on a couple samples are evaluate the power. So this is almost the reverse process of what we were just doing, where we had a product of several things multiplied together, and then our job was to create the more compact way of showing the answer. This time we have the power, and we're asked to evaluate it. And we're going to do that by writing it out as a product, and then at the end, simplifying it. Okay? So let's do that on problem 6. I notice that the base is -2/3. That means -2/3 is repeatedly multiplied, and the exponent tells us how many times it is multiplied. And so this can be written as -2/3 times -2/3 times -2/3 times -2/3. Right? I've used the exponent to indicate how many times to multiply that. Okay? But then in the key concept includes the idea of and simplify. Simplify means write it in the simplest form by performing the operations. We've written it out as multiplication problem. Let's actually perform the multiplications. Okay? So -2 times -2 is 4. This -2 times -2 is 4. And 4 times 4 makes 16 for the numerator. Now let's work in the denominator. 3 times 3 is 9. 3 times 3 is 9. And 9 times 9 is 81. And so our final answer is the fraction 16/81. That's what it means to evaluate the power, to find what its value is. Okay? Now another example, number 7, 4 to the 4th power. I want to evaluate this. And the key concept indicates how. Write it out as a product and then simplify it. So what is the meaning of 4 to the 4th power? It means 4 times 4 times 4 times 4. This is the base, and then the exponent tells us to write it out 1, 2, 3, 4 times. Okay? Now let's simplify. 4 times 4 is 16. 4 times 4 is 16, and now we could go 16 times 16. We could do that off here on the side as scrap work if we need to. I happen to know what 16 times 16 is because it's quite common in math. It's 256. Okay. Now please try number 8 and 9 on your own using the idea in the key concept to come up with the final value of each of the powers, and then the answer will be shown in a bit. So here are the answers to 8 and 9. -2 to the 6th power means 6 -2's all multiplied together, And when actually multiplying, that makes positive 64. For problem 9, 1/5 to the third power means 1/5 times 1/5 times 1/5. And when actually multiplying these together, 1 times 1 times 1 is 1. 5 times 5 times 5 is 125. There's one more key concept for today's lesson, still having to do with powers. Okay? To evaluate expressions with variables, substitute values into the variables and then simplify. So this is related to what we were just working on, but whereas these problems had numbers, right, a number, down here we have variables, letters of the alphabet. What do we do when we have variables and they have exponents? We can still do these problems, and the key concept indicates how. Okay? Substitute values into the variables and then simplify. So as a sample for your notes, here's problem 10. A squared plus b to the fourth power. Let's use a equals to 3 and b equals to 5. So when I see the letter A, I'm going to substitute a value for that variable, and we're told what to use. A equals 3. So where the letter A is, substitute in a 3, and then write its exponent by it. Okay? Now plus, what do we have to substitute in for the variable B? So fill in 5 and write its exponent by it. And what we just did was we changed the problem so that it no longer has variables in it, but instead has numbers in it. And we know how to do this problem. Okay? So we want to evaluate this by working out all these pieces. So 3 to the second power, that means 3 times 3, plus, and now 5 to the fourth power, that means 5 times 5 times 5 times 5. Let's figure out what this makes. 3 times 3 is 9, plus 5 times 5 is 25, 5 times 5 is 25, and 25 times 25 is 625. You could do that off on the margin of the paper if you needed to. And then adding these together, this makes 634. Now as another example, problem 11, let's evaluate a minus b squared. And we're going to do that because we're given in the problem that a is equal to 6 and b is equal to 2. So the first thing to do is substitute these numbers in place of these variables. For the letter A, fill in 6. For the letter B, fill in 2. Don't forget its exponent. Okay? Now we can work this out. Following the order of operations and doing the work inside the parentheses first. 6 subtract 2 makes 4. And then here is the exponent of 2 still with it. Okay? One more step. Now let's evaluate 4 to the second power. And you do that by thinking about what it means, 4 to the second power. 4 times 4. And that's 16. Okay, so we have found the value of this expression by substituting these numbers in and then simplifying out to get an answer. Now please do 12 and 13 on your own, and then the answer will be in the video in a minute. And here are the answers to 12 and 13. In problem 12, where the variable c was, we need to substitute -4. Where the variable d is, substitute 9, and then evaluate this expression. -4 to the third power means -4 times -4 times -4. And 9 to the second power means 9 times 9. Multiply these -4's together, that's -64, and multiply the 9's, that's 81. Finally, add the -64 plus the 81. Now this is a negative number and this is a positive number, so when you add these, you have to follow the rules for adding positive and negative numbers. You really end up subtracting 81 minus 64 to get 17. For problem 13, substitute a 5 for C and a -1 for D. And I wrote that here. And then 5 plus -1 makes 4. And so we need to evaluate 4 to the third power. 4 times 4 times 4 is 64. And so that was today's lesson, all about exponents and powers. There were a couple key concepts. One of them is simply the meaning of powers as being repeated multiplication, where the exponent, which is the little number in the upper corner, tells you how many times the base is being multiplied together. And another one of the concepts was how you evaluate powers by writing them out as a multiplication and then actually multiplying them together to find that answer. And the last key concept was how do you evaluate powers when there are letters of the alphabet in them. And the idea there was you substitute for those letters so that they have numbers instead of letters, and then once you've got the numbers you can work it out. Okay, so that was today's lesson on powers and exponents.